What is in red here are metal ions. So we've got 1, 2, 3, 4, 5. We've got 15 metal ions. So this is basically a bar of metal. This is a bar of metal. Okay. Now, the metal ions are arranged in a lattice structure. And a lattice structure is a situation where metal ions are arranged uniformly, side by side, and the way that they are arranged is repeating. So from the center here, the metal ions repeated themselves outwards and outwards, as well as at the top and the bottom. That is a lattice structure. Now, the metal ions are on a fixed position. In other words, metal ions do not move. They are positively charged, but they are on a fixed position. Now, we have got the electrons, which are in blue. So, electrons form a glue-like structure, and they have got free motion. So they move freely around the metal ions, and they bond the metal ions together. So this bonding is exactly what makes metals strong. To overcome this bonding, you need a very high amount of heat to overcome the bonding that is caused by the free moving electrons. Alright, now this is the reason why most metals have got high boiling points as well as high melting points. Okay, now let us look at these electrons in detail. Electrons are the ones that are free to move. But however, these electrons move in a random direction. Their movement is not uniform. So the other electron could be moving in that direction, the other could be moving in that direction, the other electron could be moving in that direction, and the other one could be moving in that direction, right? But however, when we apply heat, we cause the electrons to move in one general direction. Why? When you apply heat, for example, this side, then what it means is the electrons that are close to this side will conduct the heat. And obviously, when they conduct heat, their kinetic energy becomes more. Now, the only way away from the heat, or the only way out of the heat, is a movement from the region of high concentration, which is the source of the heat, to the region of low concentration. So in other words, a process of heat transfer will occur. It is more like the movement in diffusion, where particles move from the region of high concentration to the region of low concentration until an equilibrium is struck. So now electrons will move from my left hand side, which is the region of high concentration, towards my right hand side, which is the region of low concentration. The metal ions, they are on a fixed position. They will just conduct the heat and remain there. What moves are the electrons. So based on this principle, this is what makes metals good conductors of heat. Let us go on to look at the reason why metals are good conductors of electricity. Now, to begin with, let's remember that the electrons are on a fixed position. Now, let us remember that the electrons move in random directions. The electrons are moving in random directions. So, electrons are already there in the metal, and they are already moving in a random direction. So, let's look at how we can make them move in a uniform direction or in one direction. So, we will then take wires and we connect this metal bar to a battery. So I'll put the battery right. So this is the positive and this is the negative. Right. So now when you connect a battery causes electrons to flow from the negative to the positive. So what the battery will do, it will give an effect of uniform direction to our electrons. So the electrons, they will start flowing from the negative towards the positive. Right. What is most important is to remember that electrons already exist in metals, and they are the ones that are free to move. And when you connect a battery or when you connect electricity to a bar of metal, you then effect giving the electrons a uniform movement. So the electrons will start flowing from the negative to the positive of the battery. So based on this principle of metallic bonding, this is the reason why metals are able to conduct electricity. So these electrons, they still exist and will still be contained, and they allow themselves to be forged into any shape. So no matter the shape that a metal is forced into, the electrons still exist. Think about anything. Think about a car, a bicycle, spectacles. The electrons will still be free flowing as they are. So this is what gives metals the ability of conducting heat, conducting electricity, being malleable, as well as being ductile.